The learning targets are like a check off for you and me to make sure that everything that needed to be covered was covered. And then, of course, I also have access to the tests and things like that. I make sure that the really, really important parts that you will be assessed on are addressed. And today's lesson was a lot. Like it was a lot of really important parts. So when we talk about things being dropped, being launched, being thrown to another person, that's all projectile motion. And they all follow a basic setup like this. So if you want this, I don't know, for your own notes, then that's what I would do. But it all basically comes down to this basic setup. So the height of an object after being dropped, launched, whatever, would be described as -16p squared plus vs, or not vs, plus vt plus s. All right, the 16 we know comes from like some sort of gravity law. Some scientists found out that on Earth, our gravity gets affected by a multiple of 16. So it would have to be squared and then times by 16 as it continues to get pulled by gravity. So if there's gravitational pull, then you will see this part in the expression. If there's not gravity, then you won't see that part. You will just see maybe a velocity. So if there's a t term in there, the number that's in front would be the velocity, like it being thrown or launched with force. And then if you see a constant in the problem, then that will be your starting height. And the reason why the 16 is negative is because this measures like your distance from the ground. You would have to subtract from your starting height essentially, so it would be minus. Questions on that? So when in doubt, go back to that setup. Very rarely does it ask you to make the equation yourself, but I have seen on tests that it does. So just that's how they're making it. That's how you can interpret it. When you see them graphed, because you're probably not going to see an object being launched in this fashion, it's probably going to look more like this second one. That's our quadratic function. And there's certain parts of a quadratic function that tells us things about the situation. So we learned some new vocab today. Those of you that had the lesson already, who can tell me what the vertex is? It's the maximum or minimum, or really like the turning point of the graph. So let me show you a picture. This is in your notes that I post in Schoology. I just don't necessarily project these necessarily. But like your vertex of a graph would be like your turning point of the graph. It goes in one direction and then it switches directions. For our quadratics, it looks more U-shaped. And since our U-shapes either look like this or like this, our vertex will tell us what the maximum was, or if it's the other way, then it tells us what the minimum was. That you would look at if it said, what was the maximum height of the cannon? You would look at your vertex for that answer. Really the Y value of the vertex, not the X value. But that's vertex. The other vocab word that's new is zeros. And really that's just another word for x-intercept. So when you see something graphed, and maybe we're talking about an item being launched. Sorry, trying my best to make it look nice, but you have usually 2 x-intercepts for our quadratics at most. You could also have just 1 x-intercept, like if the vertex is on the x-axis, then there's only 1. You could also have no x-intercepts, where maybe you graph it and it's like above the x-axis. So when it asks you to identify the zeros, it's asking you to identify your x-intercepts. You have 2, 1, or none. And that usually tells you some information about the situation, like time that it hit the ground. Because if this is all supposed to be height of the ball, and this is how it traveled, our height stops at 0. And these are my zeros. So those values will tell me what time it did that. Make sense? Don't overthink it. This is how it travels. So you think to yourself, okay, my maximum height would be here. It hits the ground here. Like, don't overthink it. We're only looking at positive numbers. You can't really have a negative height or negative time. Questions on that? Okay. And domain we've talked about before. That is all the what in a function? Not necessarily. Domain refers to all the x's in a function. So like domain is all the x's, range is all the y's. You should be able to identify both, but today's lesson just focus on the domain. Like what's a reasonable time frame? Could I have negative time? Not in this situation, no. So it would probably start from 0 and end at whenever it hit the ground, whenever its flight stops, all of that stuff. So when we looked at one of the things we did today, and I don't think I have it up anymore. It ended at about 20 seconds. It hit the ground after 20 seconds. So maybe your domain would be, I don't know, 0 to 25, so that it includes the 20 seconds, something like that. And could time be a decimal? Like, could I have 2.5 seconds? So then we would also usually refer to it as all real numbers from 0 to 25. So all real numbers includes like decimals, fractions, negatives, but if I specify from 0 to 25, then now it doesn't include negatives, okay? So that's like 3 questions on the test. Any questions? Okay, so then the practice for today is the lesson 6 puzzle piece, but I'll leave this on the screen in case anyone needs to look at it as their practice. The goal is 80% or higher. My 4th hour, I have to make them, when they meet the goal, show me on their screen before they start doing free time. I hope that I don't have to do that in here. I hope that I can trust you to get it done. But if I see that, like, you know, some kids are getting their answers really fast, but they're still failing all the quizzes and tests, like that's going to be a problem. So make sure that we are trying it ourselves. I don't mind working together, but you're not helping your friends if you give them the answers. All right, so I'll leave you to it. I'll check in later, but if you have questions now, just call me over and I can help you. Words there. Everyone should always be able to submit at least 1 attempt while you're in here. There's no reason I should have missings when I like check the attendance and you were here. Unacceptable. It's like 5 problems usually. But here's today's number 5. Han accidentally drops his water bottle from the balcony of his apartment building. Here's an equation that gives the distance from the ground, D in meters after T seconds. And you're having to complete the table. So I know earlier in the lesson, we really like dissected what each part of this means. And some of your test questions do ask you to do that. More often than not, they give you the equation and ask you to do other things with it. Like graph it and answer questions. And this one, it wants you to fill out a table of values. So it gives you all of the T values. And if you look at your equation, it has a T in it. So all you really have to do to get each output, each D value is plug in the T. Everyone see that? Anytime you plug stuff in, use parentheses so the calculator reads it right. I would use a calculator, especially because these are decimals, some of them. This one's not too bad. What's 0 squared? And then 0 times -5. And then 32 minus 0 is, which also makes sense because when t is 0, that's when it started. And remember we said that was our starting height when it's the constant in the formula. So, but whatever, you have an equation and plug it in. I'm gonna plug in the rest to save myself the trouble, but you do have a table of values on your test that you'll need to do. So just take the given equation and plug in. Okay, so 32 minus 5 times 0.5 squared, that's how I would enter it all at once. Let the calculator do the hard work. And then just change the input. So when t is 1, the d is 27. When t is 1.5, d is 20.75. I need all your other conversations to halt. When t is 2, the output is 12. So that's that part. Questions on making the table of values? Then it asks, is the water bottle falling at a constant speed? Remember that constant is kind of goes hand in hand with linear. So you could try graphing it, seeing if it gives you a perfectly straight line. You could try seeing, does it increase or decrease by the same amount each time? So like 32 minus point or 30.75. That's a difference of 1.25. 30.75 minus 27 is 3.75. So is it decreasing by a constant amount? So you would put an n there. I'm gonna put that so I can see, make sure the key is right. But I would not round any decimals unless it tells me like these decimals are short enough. I would just put the whole thing in there. So type in an n for no. And that's right. So questions on this one? Questions on others? Rita? What number? Okay. Okay, so 2 rocks are launched straight up in the air. The height of rock A is given by this function. The height of rock B is given by this other function. In both functions, t is measured in seconds, height is measured in feet. Use graphing technology to graph those equations. Determine which rock hits the ground first and explain how you know. This is just like one of your constructive response questions, by the way. Just so you know. So you will need to graph both. That's what I'm gonna pull up. And when you graph it, I think it will read the function notation right, but I'm just gonna make all the t's x's anyway. So I just have to type in the second part. That's f of x or f of t. And here's my other one. Now, it says determine which rock hits the ground first. If this is how the rock travels, which one's gonna hit first? You could tell me the color. the black line. So like your x-axis is basically your ground, because if the y-axis is height, when the height is 0, that would be at the x-axis, right? So this one hits the ground first. It hits it at 1.46-ish seconds, whereas the other one hits it at 2 seconds. So now let's go back to what it said. It's the second equation, rock B, that hits the ground first. The graph for rock B crosses the x-axis at about which one? 1.5 or 2? 1.5, we saw that from the graph. Use your best estimate, which means that it hits the ground about blank seconds after launch. Which one? 1.5 seconds after launch. The graph for rock A crosses the x-axis at where? Which means it hits the ground about 2 seconds after launch. That's it. Do you guys remember what part of the graph we call that? Some of our vocab words from today. They're our zeros. The zeros give us that information when it hits the ground, otherwise known as x-intercepts. We don't want to use this one because 1, it's negative, and 2, if this is my launch pattern, you want it like after it's reached the top, then it comes down. All right, other questions? Keegan? All right, the height of a diver above the water is given by this function, where t is time in seconds, h of t is measured in meters. So like all that's true. So first, the diver begins 5 meters above the water. Would you guys say that? I'm gonna go with no. I mean, I could be wrong. I haven't done this problem yet, but if we're referring back to this equation, that gives us like projectile motion. The starting height is always the constant. All right, this would be your starting height. The constant in this equation is 3. So that would tell me that my starting height is 3, not 5. Yes. The function has 1 0 that makes sense in the situation, or the function has 2 zeros that make sense. That I'll have to graph. So it's -5 t squared. I would say don't change the order, but just because I'm back here, I'm gonna change the number in front of the x squared to -5, match. I'll change the number in front of the x to a +10. And I'll change the constant to a 3. Okay, so that's the same, I just put it in a different order. I would recommend you just put it, but when I look at my zeros, what part of my graph can I find my zeros at? What's another word for zeros? So then look at your x-intercepts, and Desmos is really nice, it lets you touch them and gives you the exact values. Does the -0 make sense? Remember, the t was for time, and it goes in the order like time, then height, time, then height. So does it make sense for us to have a negative time? So we only have 1 0 that makes sense in this situation. And that would be the positive one. So we would pick the one that says 1 0 makes sense. Any questions about it? Okay, the graph that represents h starts at the origin and curves upward. So because we're talking about a real life situation, even though Desmos lets us see like the whole coordinate plane, we're really only looking at the positive parts. So kind of pretend like anything in the negatives isn't there. Would you say that this graph starts at the origin? What is the origin? So that 0, 0 is the origin on any graph. This one doesn't even touch it, let alone start at it. So you would not pick the one that says it starts at the origin. It starts at this y-intercept of 3. Don't pick that one. The driver begins at the same height as the water level. Do you guys agree with that? Where's my water at? What part of the graph? So the diver was 3 meters above based on this y-intercept. The water level is my x-axis, so they didn't start at the water level. Plus, also like a diver probably is jumping off the diving board, so you wouldn't pick that one. Not at the same height as the water. Okay, questions on that? Only those two. Other questions at all? All right, so especially now that we've gone over like 3 out of the 5 of them, we definitely have at least like a 60% from everyone. Shouldn't be having missings or anything lower than the stuff we cover in class. If you need other attempts, you let me know. But and if you have other questions, let me know.